In this video, we'll talk about two-sided alternatives. So two-sided alternatives are more common in applications, empirical applications, than one-sided alternatives. And under two-sided alternatives, so if we set up the null, which says beta j is equal to 0, which is capturing the effect that xj has on y in the population, the alternative is basically taking an agnostic view about the sign or the effect of beta j, whether it's positive or negative, and we're basically saying beta j is not equal to 0. So when you have an alternative that is set up in this way, we are testing against two-sided alternatives, right? So this is something we do when we do not know ahead of time whether a variable definitely has a positive or negative effect. So as an example, if we look at our a previous example of in predicting final exam scores, we were using information on missed lectures, prior GPA, and achievement scores. You might have good reason to believe that prior GPA and ACT scores have a positive effect on final exam scores because these capture some sort of preparedness that you might have for a particular class, for instance, but you may not have any particular idea about whether missed lectures, the number of missed lectures, actually has an effect on final exam scores. Okay, so or what type of sign beta 1 might have, right? So you might think that somebody who comes to class may perform exactly the same way as somebody who's missing a class because maybe because of their preparedness, for instance. But in general, this is even though two-sided alternatives can be intuitively applied to examples, taking an agnostic view about the sign of beta j is generally better. So like we stated earlier, the null is beta j is equal to 0. The alternative is beta j is not equal to 0 when we are testing against two-sided alternatives. Okay. Now, remember that it is harder to reject the null against the two-sided alternative because it requires more evidence that xj actually affects y. And because we've set up the null hypothesis and alternative hypothesis, these are our first two steps in, like we had described earlier. The third step is really choosing a critical value for the test. Typically, that's 5%. And then, so this is number 3. And the fourth thing we want to do is actually have a rejection rule to carry out the test. So whenever we have a two-sided test, we are basically going to use this type of a rejection rule, which says that the absolute value of the t-statistic should be greater than the critical value. Okay, for whatever level of significance that you are carrying out the test. So if we take this to the graph and look at the probability density function, for a two-sided test, we are looking at the t-statistic to be greater than 0, or the t-statistic to be less than the t-statistic to be greater than the critical value here, and the t-statistic to be less than the negative of the critical value in this case. Okay, so since this is symmetric, you see that it says 2.06 on either side of the number line, but here you could also write this as the absolute value of the t-statistic should be greater than the critical value. Okay. So we can also use another example to explain this. So let's say we were interested in looking at the factors that affect the pass rates in the math class. Okay, so this is this data set, and you can try to study this data set at home and run these regressions. So let's say we were running a multiple regression of math 4 on these variables: lunch, student teacher ratio, average salary, and enrollments. Okay. Now you might have good reason to believe this sign of the coefficients on lunch and the rest of the variables. Okay, but for enrollments, we may not have an understanding of what we might expect. So in this case, a two-sided alternative becomes more reasonable. Okay. Now you would notice that in your data set you have 923 observations, and because this n is large, you can use the standard normal critical values. Okay, so let's say we want to run with the 5% test and the critical value is 1.96. You might have these memorized from your statistics courses, that the critical value at 10% is 1.65, critical value at 5% is 1.96, and the critical value at 1%, oops, I messed it up here. This should be 10%, and this should be 1%. Okay, and this is 2.58. Okay, so remember the rejection rules. It states that the t-statistic should be greater than the critical value, right? And so these are the critical values, and this is the strongest test, at least amongst these three. Okay, so now when we look at enrollment, when we carry out the regression, let's say we find that the t-statistic is 1.39. Notice that this is less than even the critical value at the 10% level, right? So we fail. The interpretation of this would be that we fail to reject the null at 10%. Okay, but sometimes you might want to change the regression, and this really speaks to why functional forms are important, and they might change a statistical inference. Okay, so if instead of using enrollment and average salaries in the regression, if we start taking logs of these variables, things might change a little bit, okay? Because it might be more reasonable to assume that that these variables, salary or enrollment, have some sort of a diminishing effect, okay? And so maybe you want to capture some sort of a percentage effect. Okay, so notice here that when we use log of average salaries, and oops, this is cut off, but this variable right here that's hidden is log of enrollments. Okay, this right here is log of enrollments. If we use these logs for these two variables, then we have this type of a regression. You can even estimate it yourself at home in R and see what you find. Okay, so now if we look at how do we interpret these variables, notice earlier when we had just average salaries and not the logs or enrollment, if we think about salaries, earlier we were only measuring a dollar effect, but now we are going to have some sort of a percentage effect. So you can take a look at this, and here it says that Math 4 is estimated to increase by about 1.8 points if teacher salaries are 10% higher, right? So if this coefficient that is capturing teacher salaries is 18.13, we are basically saying that as teacher salaries are 10% higher, this is the math 4 scores are going to increase by about 1.8 points. Similarly, you can look at the variable enrollments, okay, or log of enrollments, okay, which is really gonna tell you about or capture the diminishing effect. So here we are basically saying a 10% increase in enrollment is associated with a 0.26 point increase in math 4 scores, okay. And so the interpretation here is less important because we are focusing on this chapter on statistical inference. Here we can say that the t statistic was 2.09, which is greater than 1.96, right? So at the 5% level, we can say that we reject the null in favor of the alternative when we change the functional form. So you actually see the difference when we use enrollment versus log enrollment, how our statistical inference changes. Okay, so the language that you're going to use when you're thinking about rejecting the null is basically whenever we reject the null, we often say that beta hat j is statistically different from 0. Remember what we were saying in the t statistic. This is the distance between the estimate from its hypothesized value relative to the standard error of our estimate, okay? So this is going to be, since this is 0 for us, this is saying that beta hat j is statistically different from 0 if we have rejected the null, okay? And we would usually mention at what significance level we are talking about. Okay, and in the one-sided case, we say beta hat j is statistically significant when we can reject this. Okay, so just as a review, most of the times in R, when you estimate a multiple linear regression, R is going to report t statistics and significance levels for this type of a null hypothesis, okay, when beta j is equal to 0, and the critical value and the t statistic that is reported, remember, is for this null hypothesis, okay? So whenever we are hypothesizing that the effect of xj has no bearing on y, that is what is being captured here, okay? And we'll see later what happens if we change this 0 to something else.